Suddenly you are running, exercising, and you are expiring more amount of air. In addition to that, how much of the air that you can forcefully expire is, you can forcefully expire a maximum of 1100 ml in addition to the 500 ml, right? In addition to the 500 ml, so that is your expiration capacity, right? So hope by this you would clearly know. I'll get back to this one more time. Get back to this one more time. Quiet breathing, tidal value, isn't it? Quiet breathing, tidal value. So this is where your quiet breathing happens. What is this indicates, right? So this is the inspiration 500 ml. Then you have the expiration 500 ml, and again inspiration and again expiration, inspiration, expiration, inspiration and expiration. So that keep happening in the lungs. During as you go by in your day. So this is what happens. Right? Tidal value. And sometimes you need to take more amount of air. That means you need to inflate the lungs, just like how you are inflating the balloon here. You need to inflate the lungs by taking more amount of air. Yes, can you do that? Obviously you can do that. You have done it. You have taken how much of the air? You have taken 2500 to 3500 ml additional volume of air you have taken. Right? Additional volume of air that you have taken. Is it the normal? No. This one is the forced air. Because of the situation has arisen. That is why you have taken this much of air, additional set of value. And can you expire? Can you expire more than the tidal value? Obviously you can do it. How much you can expire? Is, you can expire this much. But can you completely empty the lungs? Obviously you can. How much force you apply? And this air can never be emptied. Right? So this 1200 ml of air will always remain in the lungs. Even you try to forcefully expel them out, physically you cannot do that. Physically you cannot empty this amount of air, right? And this I'll just erase this. The same thing I'll represent in a graphical pattern for you. The same thing, whatever that, so that it will be elaborately clear for you. So we are taking two axes here, right? So two axes, and from the bottom, so how much of the air that is always there in the lungs? So I'm taking one volume here. So that is RV. How much of the air that is always present? 1200 ml. So over this, how much you can expire? So this one 1100 ml. Yes. And over this, the tidal value will be happening. I'm drawing a range here. Okay. So over this, the normal process of inspiration expiration will be happening. Okay. So what is this wave indicates? So this is an inspiration followed by expiration, inspiration, expiration. That means when you inspire 500, expire 500, inspire 500, expire 500. So this will be your tidal value 500 ml. 500 ml tidal value. So this is the range we are speaking of. And beyond this, can you take up? Yes, you can take up beyond this. So I'm writing one more here. So what is this? And this one actually is the inspiratory reserve value. So this is I'm speaking of here. This one is 2500 to 3000 ml. You want to take the capacities. What capacities, inspiratory capacities you would take? Easy now, right? So this will be your inspiratory capacity. Tidal value plus IRV, your inspiratory capacity. Expiratory capacity, again, expiratory capacity, what you going to take? This one. Tidal value, what is this? Expiratory reserve value, isn't it? Expiratory reserve value. So this one is the IC, this one is EC. Yes. And what is this two? So these two, yes, we are not including tidal value here. We are including expiratory reserve value plus reserve value. So this one will be the blue thing, FRC, functional residual capacity, that is ERV plus RV. Okay, so hopefully we are clear. IC tidal value plus inspiratory reserve value is expiratory capacity, tidal value plus expiratory reserve value, and functional residual capacity RV plus ERV, functional residual capacity. If you remember this and this, right, the values and capacities will become much easier for you, very confusing, but just equate this with the balloon, right, the amount of volume that is always present in the lungs and how much you can expire, right, and what is the tidal volume that is always happening, and what is the inspiratory reserve value, and represent this with the help of the volumes. So here you take the volumes, right? So volumes you are taking, so maximum of 6,000 to 8,000 ml, 6,000 to 8,000 ml, the maximum you can take. You would get in the range of 6,000 to 8,000, 6,000 to 8,000 in the range that you would get. And so we'll further discuss this. And what is the next capacity that we have is, we have the capacity called as vital capacity. So what is the meaning of vital capacity here is, so here the volumes of air which are functionally involving the lungs, What do you mean functionally involving the lungs? Functionally there is inspiration, functionally there is expiration, isn't it? That means for the inspiration normal time we have tidal value, in the forced time we have inspiratory reserve value, in the forced time we have expiratory reserve value. Does reserve value include the function of lungs actively? No, right? It is always there in the lungs. You cannot expel it out, nor can we increase this value all of a sudden, right, by forcefully breathing in it. The lungs function is not associated with this. It's not associated with. That's why it is called as the vital capacity. That is why it is called as vital capacity, because here the lungs function is associated with it. Lungs function is associated with what are the values that are included in the vital capacity is tidal value, inspiratory reserve value, and we have the expiratory reserve value, right? Very easy. And the next one is the total lung capacity. So we call it as TLC, total lung capacity. So this is very easy. So this one is total lung capacity, vital capacity plus RV. That means, so since it is still present in the lungs, we are calling it as total lung capacity. Here we are taking the vital. What is the difference here? The difference here is in terms of the function of the lungs. So these three are associated with the functional capacity of the lungs, right? And total lung capacity, in addition to that, RV is also being used, because so here it is present, so that is why it is also being included. A very important lesson. So please do remember these capacities: inspiratory capacities, expiratory capacity, functional residual capacity, vital capacity, and total lung capacity. And inspiratory capacity, so I have represented that here as well, right? Inspiratory capacity is tidal value plus inspiratory reserve value, expiratory tidal value plus expiratory reserve value, and the functional residual capacity, these two, right? EC and RV, total lung capacity. So if I say vital capacity, what will be included in the vital capacity? So here inspiratory reserve value, tidal value, and the expiratory reserve value. These three will be included, right? So obviously these three will be included. I'll just write down. So this will be VC, and if I say TLC, so this will be TLC. So hopefully we are very clear about this. And these are all very important for the in terms of NEET exam. There will always be a question regarding this. Just imagine a balloon, right? Every time you try to do this, right? Just imagine a balloon, right? How much of the air that is always there, how much of the air, the functionally that we can expire, and how much tidal value and how much of it. Just remember this graphical representation. just remember this capacities, respiratory volumes and capacities. I'm gonna do an objective discussion on this again. So please do follow that as well. Please keep coming regularly to the channel. Yes, thank you, and you can post questions as well for me. Thank you a lot. Hopefully we are clear with this topic, respiratory volumes and capacities. Thank you.